Hello everybody, welcome back. Welcome to ACE Engineering Academy and ACE online platform. So today we are here to discuss the subject transmission and distribution. So as a part of power system and as a course of RRBJE for electrical engineering students. Right students, so here in ACE online platform we are providing the free YouTube sessions for RRBJE students to get more knowledge and somewhat easy techniques and somewhat easy concepts, right? And somewhat important concepts to understand the syllabus very clearly here. Right students? So today we are discussing transmission and distribution and myself Prasad Meghavarna. So now we are going to discuss this one. See here, this is the syllabus of entire power system. The entire syllabus of power system consisting of generation of electrical energy, transmission and distribution of electrical energy, and power system analysis. Particularly RRBJE students, you are having the fault analysis. And switchgear and protection and utilization of electrical energy is the syllabus we are having RRBJE students. So already we have completed the fault analysis session. Now we are discussing the transmission and distribution part here. Transmission and distribution part. Right students? So if you see the syllabus of the transmission and distribution, so it is somewhat more syllabus we are having compared to that of fault analysis. So we are having more syllabus in case of RRBJE for transmission and distribution. So here we have to see the first chapter, the basics, electrical design of the transmission system. So in the electrical design of transmission system, we have to see the classification of conductors very basically. So they have specifically given classification of conductors, right? What are the various types of conductors we are having in the power system network? So they are asking that one, and along with that we are going to see insulation design of the power system network. So in chapter 1 we are going to see the insulating system design and classification of conductors basically, and structure of power system also we are going to see, and what are the transformer connections we can prefer. So for that one we will see. For step up transformer, what is the connection we can prefer. For step down transformer, what are the connections prefer. All those things will be discussed in chapter 1 very clearly. And in chapter 2, the elements of the transmission line. So we have to see a basic thing of the chapter. So we can see the resistance calculation and inductance calculation and capacitance calculations of the transmission line. Just we have to see what are the formulas and what are the importance of inductance, capacitance of the transmission line. Right? So that you have to see in chapter 2. And in chapter 3, most importantly, that is the most important chapter we are having, we have to see here the classification of transmission lines, short transmission line, medium transmission line and long transmission line analysis we have to see in the chapter 3. And along with that we have to see surge impedance and characteristic impedance and velocity of the traveling wave, right? So these are the concepts we have to learn in chapter 3. And particularly the performance. So how to calculate performance of any electrical device? If you want to calculate performance of electrical device, you have to calculate percentage regulation and percentage efficiency we have to calculate. So particularly in the syllabus they are given efficiency comparisons of different systems they are given, so that we need to clearly understand chapter 3. And later on they are given about the cables, right? Underground cables we have to see, and overhead line insulators, and finally we have to see some of the concepts in the distribution system also, right? So these are the this is the complete syllabus set of transmission and distribution students, right? So you have to listen and you have to prepare these concepts very well. Clear, right? So after knowing the syllabus, what are the textbooks we can prefer? See here, the textbooks we can prefer are some of high standard textbooks we can take. So it is Stevenson and Greiger and D.P. Kothari and I.J. Nagrath. So these are the textbooks that can be preferred, so to learn the concepts very clearly at very high standard level. And in case of C.L. Wadhwa and J.B. Gupta, we are having somewhat practice questions, we can practice them. So that's why I have given these two textbooks also, right? In some of the competitive exams, right, sometimes they are copying the questions of C.L. Wadhwa or J.B. Gupta, so that it's better to practice all those questions every time. Clear, right? So every time in every YouTube session I am saying this one. So it may be RRB JE or SSC JE. So as a basic thing, so we need to practice. That is the first thing we have to do. We need to practice the questions whatever they have given in CL Wadhwa and JB Gupta, particularly for power systems. Right. So next one. So what is the practice set? So if you want to crack, if you want to get maximum marks in power system, so what is the practice set we have to maintain? So for RRB JE students, we have to solve so somewhat simple ES engineering services prelims questions, right? So we have to solve somewhat ESC prelims questions and somewhat so PSC questions like ISRO, DRDO, right? And ONGC, BARC, like that we are having. So that those type of questions you have to solve. And previous state board questions, electricity board questions like SPDCL, Transco, Genco, like every state is having, right? So those type of examinations in electrical department. So try to download them and practice them. And finally, previous RRB JE and SSC JE questions also you have to practice to get the maximum marks. So by seeing these questions, you can get an idea, right, up to how much level I have to go, right? So particularly if you see the previous RRB JE and SSC JE questions, you can get an idea up to how much level I can prepare for power systems. Like not only for power system, for every subject, you can get an idea. So what is the highest possible level I can prepare? Clear, right? Right. Now, so first of all, whenever we are seeing the syllabus here, as a basic thing, in chapter 1, we are having the electrical design of the transmission system, right? Students, the electrical design of the transmission system is consisting of insulating system design and the conductor system design. So in the conductor system design, we are having the classification of conductors. As a basic part, whenever you are selecting a conductor for a transmission system, just I want to ask you one thing here. So what is the importance of transmission line in power system? The importance of transmission line, it transfers electrical energy from remote generating station to the load center. Is it clear, right? The transmission line transfers electrical energy from the remote generating station to the load center. That is the basic importance of the transmission line. Now, whenever you are selecting a transmission line, what are the properties we can prefer for a transmission line? Before going for the classification of that one, so I want to give you what are the properties of the transmission lines we can prefer. Clear, students? First of all, we will see what are the properties of transmission line. So first of all, so let me welcome. So who are the students we are having here? Right. So Durga Prasad Chari is there. So he is attending almost all the sessions. Very good, Durga Prasad Chari. So irrespective of what is the session, so you are very right. Yeah, not yet, Bhushan, it's not came yet. Anita, good evening, and Amala Gracie, good evening. Right, good evening everybody. Right. So first of all, we'll see what are the properties of the transmission line. Tell me, students, the properties of transmission lines. Properties of transmission lines. Can you tell me some properties of the transmission lines? Can you tell me the properties of some transmission lines? Right. So the first property we can give, it should have high conductivity. That is the basic property of a conductor. The transmission lines are nothing but the conductors. The first property we can take it as high conductivity. It should have high conductivity. Just look at here, students. Whenever you are saying high conductivity, in some textbooks it will give it as high conductivity. In some textbook it will give it as low resistivity. Both are same only, na? Low resistivity. High conductivity or low resistivity. Whenever you are saying low resistivity, it is having low resistance. It is also same point. Whenever it is having low resistance, it is having low power loss, right? It is also the same point. Low power loss. Whenever the line is having low power loss, we can say it can transfer high amount of power. High power transfer capability. High power transfer capability. High power transfer capability. One more point. So whenever the line is having less losses and it is transferring high amount of power, we can say it is having high percentage efficiency. High percentage efficiency. Right, students? Just check it here. You have given only one point here, high conductivity. High conductivity will leads to low resistivity. Low resistivity is leading to low resistance and low power loss, high power transfer capability and high percentage efficiency. We have given only one property of transmission line. All are same only. All are same only. They are not different properties. Only one property. Clear, right? Next one. What is the next property we can give? What is the next property we can give? The transmission line. So whatever it is having low resistance and as well as it should have low voltage drop. The transmission line should have low voltage drop. It is having less power loss, along with that one it should have low voltage drop. Tell me, students, how can you get low voltage drop? You can get low voltage drop whenever the transmission line is having less resistance and less reactance. So in transmission line, we can model the transmission line as R plus JXL. We are getting the voltage drop in the resistance, series resistance and the series reactance of the transmission line. Right? Now, the series resistance already I have given here. It is having low resistance. So that I am giving low reactance. Low reactance. What is the advantage of low voltage drop? Whenever the transmission line is having low reactance, so it is having or low voltage drop, it is having less percentage voltage regulation, right? So it is having low percentage voltage regulation. Voltage regulation. Clear, students? So for a transmission line, we have to calculate percentage voltage regulation. What is the percentage voltage regulation formula we are having? The percentage voltage regulation formula for transmission lines as well as for generators, right? So we can write. So percentage voltage regulation is nothing but V no load minus V full load divided by V full load into 100. Why? Because for generator and transmission line, we know the full load voltage. For example, if you are having a 220 kV transmission line, that 220 kV is full load RMS line to line voltage. As it is full load voltage, we are taking denominator as V full load, right? Similarly for generator, if you are saying 11 kilovolts generator, that 11 kilovolts is so full load line to line RMS voltage. So as we know full load voltage for generator and transmission line, we are using V full load here. But suppose if you take a transformer, for transformer which voltage you know? For transformer, we know the no load voltage. No load voltage. Transformer is always rated for no load voltage. That means 33 kV bar 11 kV. 33 kV bar 11 kV. That 33 kV is a no load voltage and 11 kV is also no load voltage. And the transformer is the only element. Transformer is the only element which is always rated for no load voltage ratings. No load voltage ratings. As it is a shunt element. As it is a shunt element. But whereas generator and transmission line. Generator and transmission line are the series elements, but the transformer is a shunt element, so that voltage will no load voltage will appear across the terminals. That's why. So to give more insulation, to give more protection, we always design the transformer for no load voltages, not for the full load voltages. So, but whatever it may be, no need to deviate the topic here. Just check here. That is the second property of the transmission line. What is that? So it is having less percentage voltage regulation and high percentage efficiency. So these are the two basic properties. Along with this, what are the properties we can prefer? The next property, commonly we can say it should have high mechanical strength. High mechanical strength. High mechanical strength. Along with the high mechanical strength, if it is having high tensile strength. High tensile strength. So whenever conductor is having high tensile strength, so it will be straight between the points. It is lying straight, right? So it is not at all having any sag. It is not at all having any sag. So high mechanical strength and high tensile strength will lead to low sag. Low sag on the conductor. That is the one more property we can take. And one more property we can take, every conductor should have high thermal conductivity, right? High thermal conductivity. High thermal conductivity. Thermal conductivity is nothing but heat transfer. So that we can say high heat transfer. High heat transfer. What is the advantage of thermal conductivity, students? What is the advantage of thermal conductivity? A conductor is having high thermal conductivity means it can transfer the heat from one location to the other location. Right? Suppose if you are taking a plastic pen like this or rubber pen like this, whenever you are having a rubber pen, with one matchstick I can melt this one, rubber, whenever it is rubber or whenever it is paper. So paper and rubber are insulators. With one single matchstick I can melt this one. But whereas if you take the same size of iron piece or steel piece or aluminum piece or copper material, so it is not possible to melt that one with 10 match boxes also. Why? Because they are transferring the heat from one location to the other location. Whenever rubber material is melting on this side, we can touch on the other side. Why? Because there is no heat transfer from one location to the other location. Whenever paper is melting, right? So it is possible to touch that one. But whenever iron or steel, any metals, right? Whenever they are melting, so it's not possible to touch the other end. Why? Because they are transferring the heat. So what is the advantage of transferring the heat? Whenever they are transferring the heat, we can say they are having high melting point. That means they can withstand more temperatures. They can withstand more temperatures. Clear, right? So as they are transferring the heat, so I am giving some temperature here, it is transferred, right? So that I have to give one more time. That's why, so they are having high temperature withstanding capabilities. That is the one more property we can take here, students. So high thermal conductivity, high heat transfer capability, we can say it is high temperature withstanding capabilities. All are same. High temperature withstanding capability. Withstanding capability. Right, students. Along with this, how many remaining properties we can take? The conductor should have, right, low temperature coefficient, right? So low temperature coefficient. Low temperature coefficient. Whenever the conductor is having low temperature coefficient, the variation of resistance with respect to variation of temperature will be very, very less. So we can take resistance R2 is equivalent to R1 into 1 plus alpha into T2 minus T1. So whenever you are having more temperature variation also, so whenever alpha is very, very small, 0.001 like that, so even though if you are having more temperature variation, the resistance variation will be very, very less. Clear, right? And one more property we can take, so the conductor should not chemically interact with surrounding environment, right? So it should be chemically inert. Chemically inert. Chemically inert. So we can say simply there is no corrosion for conductor. No corrosion. No corrosion for a conducting material. Along with this, remaining properties, it should be more flexible. It should be more flexible. So high flexibility we can take. So high flexibility. So high flexibility will be available whenever the conductor is weight less, right? So less weight. We can say it is less weight. Right. Next one, it should be available in the universe. So by giving all the properties, we are saying that those type of materials are not at all available in the universe, right? So it should be available, more availability. More availability. And finally, it is having low cost. It has to give all the above properties under low cost. Under low cost. So these are the properties that are preferable, students, for a conducting material. For a conducting material, right? So I think it is very clear for you. Yeah. Very good. Hi Upender. Hi Akshara creates. Hi Santosh Kumar. Right, students. Right, students. So these are the properties we are having. Now tell me, what are the materials we can take? What are the materials we can prefer for conducting? So the materials, tell me students, from highest value of conductivity, conducting materials. Conducting materials. Tell me students. So the best conductor. What is the best conductor in the universe? Silver, copper, right? Gold, aluminum, right? So like that we are having. So brass, bronze, right? Nickel, platinum, right? So we can take, so brass, bronze, nickel, platinum, right? Iron, steel, lead, right? Stainless steel. Like that we are having the elements, right? So in this, first of all, the elimination process, we have to eliminate. So we have to eliminate, right? So we can eliminate first of all platinum because of very high cost, and we can eliminate gold, and we can eliminate silver. Basically, they are very high cost, and it's not possible to give protection for them, right? So it's not possible to protect that platinum and gold and silver conductors practically, right? And next one. Tell me, can I eliminate stainless steel? Why? Because it is last in the list, and I can eliminate lead. Why lead can be eliminated? It is having less thermal capabilities. It can melt at low temperatures. That's why we are using that one in the soldering, right? So lead is having less thermal capabilities, right? And we can eliminate steel and iron. Steel is an alloy of iron. So both will be corrosed. So the problem with this will be corrosed, right? And we are having nickel, brass, bronze, right? So nickel, brass, bronze they are highly brittle. So we can use in very small rated missions, right? Nickel, brass, bronze. And finally, there is a very big competition between copper and aluminum. So finally, both win the race. We cannot use aluminum where copper is using. We cannot use copper where aluminum is using. So we have to use copper. So for very small distance power transmission, suppose in your home, so the house wiring should be given by copper. And if you want to construct a mission, transformer, right? Or if you want to construct a DC mission, if you want to construct any motor or any generator, the winding should be given by using the copper, right? So, and whenever you are having somewhat long distance transmission, we have to go for definitely aluminum conductors, right? So copper is preferred for very short distances, right? For example, we can give house wiring, and along with that we can give electrical machines, right? And aluminum is preferred for long distance transmission, right? So for long distances. Clear, right? So there are several things why we are preferring aluminum compared to that of copper. So aluminum is having less cost compared to that of copper cost, and the aluminum weight, the weight of aluminum, or we can say the density of aluminum, so is less than that of copper, right? That's why aluminum is more flexible than that of copper. And also we can say the aluminum conductor, on the surface of aluminum conductor, the corona formation will be less compared to that of the copper conductor, right? So that we can say the advantages of copper, aluminum than copper, right? Advantages of aluminum than copper. What are the advantages of aluminum than copper? Right, tell me students. Low cost, right? We can say low density, and we can say less corona formation. less corona formation. Right? So you can say, so whenever you are taking same resistance from, if you want to take same resistance from aluminum conductor and copper conductor, the corona formation on aluminum conductor is less than that of the copper conductor. So these are the major reasons why you are preferring aluminum conductor than that of the copper conductor. Now tell me, what is the classification of conductors? The classification of conductors. Classification of conductors. If you see, the conductors are classified. First of all, a solid conductor. And the next one is homogeneous stranded conductor. Or we can call it as all aluminum conductor. And composite stranded conductor. We can also call it as ACSR conductor. And we can have the hollow conductor. And finally the bundle conductor. So these are the conductors we are having, right? So first of all, the initial conductor is the solid conductor. As this conductor is having high skin effect. So whenever you are giving some alternating supply, to a solid conductor, the phenomena that the electric current concentrates more on the surface and very less at the center, that we are calling it as skin effect, and that will be more dominant in the solid conductor. So to avoid that skin effect, so we have introduced stranded conductors. So that it is a stranded conductor. It is also a stranded conductor. In case of stranded conductors, the skin effect will be reduced, right? So that here it is having low skin effect. But the problem with the homogeneous stranded conductor or all aluminum conductor, it is having more sag, right? So the homogeneous stranded conductor is having less skin effect but more sag. To avoid that, we have introduced ACSR conductor. We have given some steel, so to increase the tensile strength of the conductor. So finally the sag will be reduced, right? Therefore these conductors, ACSR conductors, are having low skin effect because of stranding property, and less sag. And as these are stranded, these two conductors' surface is not smooth. So because of non-uniform surface, not smooth, rough surface, they are having more corona formation. But whereas on solid conductor, the surface is very smooth. Because of smooth surface, it is having less corona. Clear, right? Right. So these are the basic type of conductors we are having. And later on, we have introduced two separate conductors. So hollow conductor configuration and bundled conductor configuration. So particularly they are used to reduce corona. So the basic application of these two conductors to reduce corona. Right? So along with this, we are having several conductors like expanded ACSR conductors and all aluminum alloy conductors, right? Anaconda conductors. Like that, we are having several types of conductors, right? So these are the more important things that you have to learn here. Clear, students? So first of all, I am going for first question. So try to answer the question here. The first question. The main disadvantage of solid conductors is, what is the main disadvantage of the solid conductor? What is the main disadvantage of the solid conductor? Please give me the response here. What is the main disadvantage of solid conductor? High corona formation, or high skin effect, high sag, or high current density? What should be the answer? What should be the answer? So Santosh Kumar, Durga Prasad Chari, Amala, Akshara creates, yeah, Upendra Nani given first. It is having high skin effect. Very good everybody. So very good. So already I have given already. So what is the main disadvantage of solid conductor? They are having high skin effect. They are having high skin effect. So high skin effect is the major disadvantage of the solid conductors. Very good everybody. Very good. Right. We'll go for the next question. Just check here. The use of ACSR conductors. What is the use of ACSR conductors in our power system network? Just check here. The reduce skin effect, they are given in option A, increase sag and reduce corona. Option B, reduce skin effect, reduce sag and reduce corona. And option C, reduce skin effect, reduce sag and increases corona. And option D, reduce skin effect, increases sag and increases corona. Please go through the options clearly. And try to give me the answer. Yeah, they are available. Just go through the online platform. So the faculties don't know about those costs, right? So just go through the ACE online app. So just try to download that, and you will get every information, bachelor life there. Right. So Akshara creates, given it is option B. And Utkarsh given option C. Yeah. Akshara creates changes his answer. So Upender given option C. Durga Prasad, please check it. ACSR conductors reduce corona? Are the ACSR conductors reduce corona? Please check it everybody. Anita very good. Upender very good. Akshara very good. Utkarsh. Very good. Please check it everybody. Are the ACSR conductors are going to reduce corona? Please check it. So they are having ACSR conductors are having low skin effect and less sag, and because of non-uniform surface, right? So surface is not smooth, it is rough surface. So that we are having more corona, right? So the electric field intensity is more on rough surface, right? Whenever you are having more sharp points, so at the more sharp points, we are having more electric field intensity, right? Yes, I'm the person I have taken. So the power system analysis I have taken, right? So please check it everybody. So the correct answer is, it is option C. Reduce skin effect, reduce sag and increase corona. It's not going to reduce corona, the ACSR conductors. So please go through this question everybody, somewhat most important. High skin effect. Skin effect will be more in which conductor? It will be in solid conductor. David Raj. Right. Good evening. Right, students? So high skin effect will be more in case of solid conductor. That's why to reduce the skin effect, we are going for stranded conductors. So what are the stranded conductors we are having? The stranded conductors are these two. So homogeneous stranded conductor and a composite stranded conductor, both are stranded conductors only. So because of stranding property, they are having less value of the skin effect. Very good. Clear. So we'll go for the next question. To maintain the same current density, in case of hollow conductors, compared to solid conductors, the radius of hollow conductor will be. Just go through the question. To maintain the same current density, in case of hollow conductors, compared to solid conductors, the radius of hollow conductor will be. Options are same as that of solid conductor, more than that of solid conductor, less than that of solid conductor, and any of the above. What may be the answer? Students? Any answer can I expect here? To maintain the same current density, I want to maintain same current flow in both solid conductor and hollow conductor. Option B, more than that of solid conductor. Very good. Very simple question only, na? Very simple question. Clear, right? So these are the questions which are very, very important for particularly for RRB JE aspirant students. Right, very good. So in case of hollow conductors and bundled conductors, just check here students. So they are particularly designed to reduce corona phenomena. So whenever you see the hollow conductor, so if you are taking a solid conductor, if this is the radius of the solid conductor, suppose if it is taking a current of 5 amperes, if you want to take the same current by using the hollow conductor, the radius of hollow conductor will be somewhat more. The hollow conductor is a what? It is a cylindrical drum type of conductor. So if you want to take same 5 amperes from hollow conductor, and this is the solid conductor, the radius of hollow conductor will be very high compared to that of the solid conductor. Clear, right? So you can say the radius of hollow conductor is more than that of the solid conductor. Clear, right? Very simple one. We'll go for the next question here. Just go through the question, next one. A 3-phase 4-wire system is commonly used for. So this question, many of the students already seen this question, but I have given this question for particularly for RRB JE students. Tell me, a 3-phase 4-wire system, where we can have a 3-phase 4-wire transmission system. So Anita can give Upender and Durga Prasad Chari, right? Some students already have attended TSPSC or TSSPDCL classes, so you can give the answer. What is the answer for this question? And RRB JE students, you can also try it. So a 3-phase 4-wire system is commonly used for primary distribution, secondary distribution, primary transmission, secondary transmission, right? So Bhushan, it is secondary, okay, but secondary distribution or transmission? Yes, very good, very good. Now it is clear. So someone given it is option D. Akshara creates it's not secondary transmission. It's not secondary transmission. It's not secondary transmission. It should be secondary distribution. Secondary distribution. So please change your answer. So Akshara creates and yes. Economical means 3-phase 3-wire only. Economical means 3-phase 3-wire. Durga Prasachari, 3-phase 3-wire is economical. Number of conductors will be less. But even though it's not economical, we have to go for 3-phase 4-wire system whenever you are having 440 volts. Whenever you are having 440 volts, to connect single phase loads for 440 volts, we are going for the 3-phase 4-wire system. So if you see the transmission system, students, so we are having the generator and we are having the feeder here and we are having the distributors here, right? We will place the transformers. This is the step up transformer we are having. This is the transmission line. This is the step down transformer we are having. For example, if it is 11 kilovolts generator, we are stepping that one from 11 kilovolts to 220 kilovolts. So we are transmitting at very high voltage, 220 kilovolts. Why? Because we are having lot of advantages whenever we are transmitting at high voltage. So 220 kV is the primary voltage divided by, and we are stepping down that one to suppose 33 kV. So that this line is a 33 kV line. 33 kV distribution line. We can connect all 33 kV loads here. And we can tap one more line here, and we can connect one more transformer here. And suppose if it is 33 kV bar 11 kV, 33 kV bar 11 kV. So that this is a 11 kV line, and you can connect all 11 kV loads here. And we can take one more transformer here, and we can connect 11 kV bar 440 volts or 400 volts. And normally it is rated for 415 volts nearby. 11 kV bar 440 volts, right? So this is 440 volts line. And from here we can take a single phase transformer, 440 volts bar 220 volts single phase transformer. This is the single phase distributor wire, and here we are having the domestic consumers. But the most economical connections of the transformer, right? So for transformer connection, the most economical connections are, so here we have to place delta, star grounded connection is the most economical connection for step up. For step down, star grounded and delta connection. So this is also step down, right? Star grounded and delta connection. This is also step down, right? You have to take it as star grounded and delta. Star grounded and delta. But whenever you are seeing 440 volts, for 440 volts we need to give fourth wire. So as we are giving fourth wire, so the secondary side should be star grounded and the primary side should be delta connection. So even though delta star grounded connection is not economical, still we are going for that delta star grounded connection because we have to provide the neutral wire for a 440 volt system. 440 volts system. So here 11 kV transmission or distribution, 11 kV transmission or distribution, 220 kV transmission or so 33 kV distribution. So up to so 11 kV, 33 kV, 220 kV here. So these levels will be done in 3-phase 3-wire. 3-phase 3-wire. They are economical. But whereas 11 kV, that is 440 volts, it should be done in 3-phase 4-wire. 3-phase 4-wire. And single phase it should be done in single phase 2-wire. Single phase 2-wire. Right? So these are the things. So you can remember delta star grounded connection is economical for step up and star grounded delta is economical for step down, right? So try to remember, we are having calculations in the transformers, so why they are economical. So the star connection, the secondary line voltage will be automatically stepped up by √3 times compared to that of the delta connection, primary line voltage, and in case of this one, the secondary line voltage will be automatically stepped down by √3 times compared to that of the primary line voltage of star. So because of that one, they are more economical. Clear, right? So this is what we are having. So whenever you are having 440 volts, this 440 volts and 220 volts are called as secondary distribution. But primary distribution are 11 kilovolts, 33 kilovolts, 66 kilovolts, like that we are having the primary distribution, right? We can give. So 66 kV, 33 kV, 11 kV. These are HV distribution, or we can call it as primary distribution. Primary distribution. So we have to do this one in 3-phase 3-wire. 3-phase 3-wire. But coming to 440 volts and 220 volts. 440 volts and 220 volts. 440 is 3-phase 4-wire. 3-phase 4-wire. And coming to 220 volts, it is single phase 2-wire. These two are what? Secondary distribution. Clear, everybody? So that we have to use 3-phase 4-wire system in the secondary distribution, students. Secondary distribution. Right. So the correct answer is secondary distribution. 3-phase 4-wire system is used in the secondary distribution. So I am going for the next question here. So try to solve the next question. In ACSR conductor, steel core is provided too. So what is the purpose of providing steel core? Yeah, MPSC 66 kV is a transmission voltage as well as distribution voltage also there. 66 kV transmission voltage levels is there, so we can distribute also. Yeah, we can transmit as well as distribute. 33 kV we can transmit. If you are having, just check here, students. Suppose if this transmission is 11 kV bar 33 kV, we are transmitting only in 33 kV, right? But we are having 66 kV distribution voltage levels also, right? Right, no need to confuse. 66 kV also comes in transmission as well as in distribution, both. So in ACSR conductor, steel core is provided to increase the tensile strength, and to reduce the sag on the conductor. Yes, very good. Next question. The main function of electric power system is to, what is the main function of electric power system? What is the main function of electric power system? So it is transmit energy with maximum efficiency, generate energy with maximum efficiency, store energy with maximum efficiency, convert energy with minimum efficiency. So what should be the answer? What should be the answer for this question? The main function. What is the main function of electric power system? It has to transfer energy at high efficiency, or generate energy at high efficiency, or store energy at high efficiency. It should be definitely, it has to transfer with minimum losses and high efficiency. It has to transfer with minimum losses and high efficiency, students, every time. Clear, everybody? Right. So we have to transfer the electrical energy with maximum efficiency and minimum losses. Very good, very good. Right. Next question. In power system simulation studies, the transmission line is modeled as pi. Why we are modeling as transmission line as pi model? Because what they are asking, the number of nodes are more in T model, the number of nodes are less in T model. In both the cases, pi and T model, number of nodes are equal. There are no nodes at all either in pi or T model. The number of nodes are more in T model, or the number of nodes are less in T model. So why we are going for the representation of transmission line as a nominal pi model? Nominal pi model, right? So particularly if you are seeing the classification of transmission line, students, we are having short transmission line, right, up to 20 kilovolts and 80 kilometers, and we are having medium transmission line, so from 20 to 100 kilovolts and 60 to approximately 160 or 150 to 160 kilometers we are having, right, medium transmission lines, and beyond that one we are having the long transmission lines. This is the basic classification we are having. Now in this, in case of short transmission line, we are neglecting the capacitance value because of shorter lengths. We are having less charging current. So whenever charging current is less, so we can neglect the effect of capacitance in the transmission line. So in case of short transmission line, we are having only resistance and inductance. And coming to the medium transmission line, so as the length is more and the voltage level is also more, the charging current will be more. Whenever the charging current is more, we should not neglect the capacitance in the transmission network, so that we have to add the capacitor. But in case of the medium transmission line, based on the capacitance placement, we are having several connections. We can place the capacitor at source side, we can call it as source capacitor model. We can place the capacitor at the load side, we can call it as load condenser model. We can place the capacitor at middle side, we can call it as middle capacitor model or nominal T model. And we are placing the capacitance divided into two parts and connecting at source side and both sides. We are calling it as, so both sided capacitor model, or we can call it as nominal pi model. They are saying that why nominal pi model is best. Actually, I will give, finally, two things I can give. We are having source capacitor model and load capacitor model and nominal T model or middle capacitor model and nominal pi model. So just try to remember these points, students. They are very, very important. Source capacitor model and load capacitor model they are not symmetrical lines. They are not symmetrical. You can calculate ABCD parameters for these two. We are getting A is not is equivalent to D for these two. A is not is equivalent to D. So these two are unsymmetrical lines. So that majorly, so if you want to model any transmission line, the transmission line should be both symmetrical as well as reciprocal. Those are reciprocal but not symmetrical. But whereas for nominal T and nominal pi, so in both the cases A is equivalent to D, they are symmetrical. So they are symmetrical. Here they are unsymmetrical but reciprocal. But whereas in case of nominal T and nominal pi, these two are symmetrical as well as reciprocal. See here, if just see here, so compared to these two are having unsymmetry problem, so that the best models we can say nominal T and nominal pi. And they are asking which is best in these two. Which is best in these two? If you want to select in these two, if you take here, this is T network representation, right? Here we are connecting the capacitor value, and this is the pi network representation. This is the pi network representation. So if you see, this is the first bus and this is the second bus, and this is the first bus and this is the second bus. So in case of pi model, we are having two buses for one line, But whereas in case of T model, we are having one bus here, and this is extra bus or extra node. So that the number of nodes in case of T model are always more. So whenever you are finding the bus admittance matrix or the bus impedance matrices, as we are having more number of buses, the size of those will be increased. So that we need more storage requirement. We have to find more number of elements. So whenever you are calculating Y bus or Z bus for a T network. But whereas for pi network, so only we are having one bus here. Y11, Y22. If you are calculating Y11, that means Y bus. So you have to calculate Y11, add all the admittances connected to bus 1. Y22, add all the admittances connected to bus 2. But coming to here, you have to calculate Y11, you have to calculate Y22, along with that, we have to calculate this extra node admittance also. So that for every line, one calculation will be extra. That is one node is extra. Clear, right? So that is the major drawback. So that what is the disadvantage of this nominal T model? So in case of nominal T model, we are having more number of nodes. The number of nodes are more in case of the T model. But remember students, everything is good, perfect. But if you want to give compensation for Ferranti effect, what is Ferranti effect, students? The Ferranti effect is the phenomena whenever the transmission line is operated under no load condition or lightly loaded condition, the receiving end voltage may be more than that of the sending end voltage. So if you want to give compensation for Ferranti effect, so we have to check in which line we are having the highest value of Ferranti effect. So that if you want to give compensation for Ferranti effect, that should be given based on the load capacitor model. The load capacitor model will experience highest value of Ferranti effect, right? Highest value of receiving end voltage, right? That's why the Ferranti effect compensation should be given based on the load capacitor model, not based on nominal T or not based on nominal pi. The Ferranti effect compensation should be given based on the load capacitor model, right? The Ferranti effect compensation should be given based on this line. So based on this one, based on this line, Ferranti effect compensation will be given. Clear, right? Right, students. So we'll go for the next question. Yes, very good. Ankit. Right. Yeah. So I'm going for the next question here. Very good, everybody. The characteristic impedance of a line in ohms with series impedance of 0.1 ohm per unit length and shunt admittance of 0.001 ohm mho per unit length is given by. Tell me what is the answer? What is the characteristic impedance? So whenever series impedance and shunt admittance are given, what is the value of the characteristic impedance they are asking? What is the characteristic impedance formula? ZC. What is ZC, students? The value of ZC is root of Z by Y. You can substitute those values here. What is Z they have given? 0.1, and what is Y they have given? 0.001. 0.001 Z by Y. So series impedance is given 0.1 ohms and shunt admittance is given 0.001 mho. Right? Please check it. Is it B? Anita, is it B? ZC. Please check it. It will be 0.1 into 10 power minus 3. 10 power plus 3. 10 power minus 3 in the denominator, it will be 10 power plus 3. So it will be root of 100 square. It will be 10, not 100. It will be 10. Yes, it will be 10. Right? So no need to give. So that much faster. No need to give that much faster. Please give the accurate solutions. Right? Students, Akshara, please check it. So it should be 10. It's not 0.1 or 100 or B or anything. So please check it. Right? So no need to give that much faster answers in examination also. So go slowly. Try to give the perfect answers. This question may be very easy. Most of the students can give the answer. But unnecessarily, so because of this overspeed, right? So we need to we are going to give some wrong solutions here. Right? So I'm going for the next question here. Just see the question here. Yeah. The main limitation of power handling capability of short length transmission lines and cables. So what is the main limitation of the power handling capability of short length transmission lines and cables? What is the main limitation here? Tell me, students. So they are asking here, it is the power factor or stability or thermal effect limit or conductor size. So what is the main limitation for power handling capability of short length transmission lines and cables? So Akshara creates is given very good, perfect. It is option C. It is thermal effect. So in case of, yes, very good, right? So in case of short transmission lines, and cables, so the power handling capability or loading capability can be reduced by thermal effects, thermal capability. And whereas in case of medium lines, the power handling capability or loading capability will be reduced by, in case of medium lines, it will be reduced by what? So it will be reduced by voltage drop limits. And whereas in case of the long transmission lines, the power handling capability will be reduced by the stability limits. Clear, students? So these are the limits we are having here. Very good. Stability for long. Very good. So Hare Krishna, it's not option B. Option B is for long line. Hare Krishna, option B is for long line. So please check it. And for medium line, it will be voltage drop. For short transmission lines and cables, it will be thermal capabilities. As the size of conductor is very small in case of short transmission lines. And in case of cables, we are having the insulation. So as we are having more amount of insulation, right? So that means the insulators, whatever we are having in cables, the insulators are unable to withstand more temperatures. Why? Because practically the insulators, whatever we are having, they are not having that much heat transfer capabilities. As they are unable to transfer the heat, they can melt wherever they are finding more heat. So that in case of the short transmission lines and cables, so they should be protected, right? So based on the thermal limits, right? So now we'll go for the next question. It is with respect to the cables, the insulation resistance and the conductor core resistances of a cable of 10 km length are 10 mega ohms and 20 ohms respectively. If the length of the cable is doubled, if the length of the line is doubled, then these resistances respectively are. So what about the values of these resistances? Tell me the answer for this question. the insulation resistance is given 10 mega ohm and conductor resistance is given 20 ohm. When line is doubled, line length is doubled, what happens to the insulation resistance and conductor resistance, right? So we know the insulation resistance is always inversely proportional to the length, and whereas the conductor resistance or core resistance is directly proportional to the length. So that the resistance of core always increases with the length, and the resistance of insulation is whenever length is increasing, the resistance of insulation will be reducing. Clear, right? So therefore, whenever line length is doubled, insulation resistance will become half, so that 10 will become 5. So if you see, so it will be 5 here and 5 here. So that option A and option C are not correct answers. And finally, we can see whenever core length is given 20, core resistance is given, and core length is doubled. When core length is doubled, its resistance will be doubled. It will become 40. Clear, students? So that the correct answer is 5 mega ohms and 40 ohms. Right? So these are the questions we are having for today's session. I think everything is clear for you. Very good, everybody. Your response is very good. So particularly Amala Gracie and Anita. So Rahul, Ankit creates Uma, right? Bhushan, Hari Krishna, Upender, right? So some of the students, right? So and also Siva Prasad, Durga Prasad, right? So these are the questions we are having, students. I think everything is understood for you. And if you are having any doubts, so I have given already my mail. So powersystems.prasad2010@gmail.com. So you can send your doubts to that one. So that's all for today's session. Thank you, everybody.